Okay, so this next one is a you try. So if you will pause the video and give it a shot on your own, and then we'll come back and look at it together. Ready? You try. Okay, so surface area, we got our formula written down, 1/2 perimeter of the base times slant height plus area of the base. So we have 1/2. My perimeter of the base, there's 6 sides, so 12 for each side. Side length is 12 times 6 sides, and then times our slant height. Our slant height is not given to us, and then we're still going to have to find the area of the base. So let's look at this 45, 45, 90 triangle here, because one side of that 45, 45, 90 is our slant height. Our hypotenuse is our lateral edge. That's not really important. But what we do know is that if a whole side, a whole base that is, of this triangle is 12, then half of the base would be 6. So on a 45, 45, 90, this would be 6, 6, 6 square root 2, with our hypotenuse being 6 square root 2. So our lateral area will be 6 as well. So now we have 1/2 times 12 times 6 times 6 plus area of the base. Now the base is a regular polygon, so we're going to get to do 1/2 apothem times perimeter for the regular polygon. And so let's just draw that hexagon over here so we can look at it a little better up close. And we know that each side is 12. So this is the base that I'm looking at right here, okay? So that's what this is there on the bottom of this shape that I've redrawn over here at the side. Okay, so we know that our strategy is we're going to do 1/2 AP, 1/2 apothem times perimeter. We already know the perimeter of this hexagon is going to be 12 times 6. We already know the 1/2. What we don't know is the A. So let's use our strategy for this. We split this up into 6 triangles, 6 equivalent triangles. And by doing that, that gives us 6 central angles that are all congruent. They're all equal. So 360 divided by 6, each one would be 60. So that means each of these angles here is 60 degrees. And so when we drew in that apothem, don't forget that further subdivides that 60 into 30 and 30. So now we have a 30, 60, 90 there in yellow. And we know that 12 can be split into 6 for this side and 6 for this side. So if across from 30 is 6, then across from 60 degrees should be, our apothem should be 6 square root 3. Okay, so let's put all this in our calculator. 1/2 times 12 times 6 times another 6 plus 1/2 times 6 square root 3 times 12 times 6. So be careful in your order of operations. If you're working this as 2 separate steps, find the blue and find the green and then add them together. You're also welcome to put this all in your calculator, all in one step. So I'm going to put mine in the calculator here so that you can see what this looks like. So this would be 1/2, I'm going to call that 0.5 times 12 times 6 times 6 plus 1/2 times 6 square root 3. Remember to arrow to the right to get out from underneath that square root sign, times 12 times 6. The parentheses aren't necessary. Okay, and so I'm getting 590.1 for my answer. And that would be yards squared. All right, the last problem here, let's look at part C. So on this one, I hope it doesn't throw you off that it is an upside down pyramid. Let's look at what else we have. This 29, if you can't tell, that is going straight up the middle. That is not a slant height. That's an actual height of the pyramid. We do have the slant height drawn in, even though it's not given to us. We don't know this length here yet anyway. All we really know is that we have a square on the bottom and that the actual height is 29. So this is going to be interesting. So I think what I'm most interested in is that green segment to start with. And so since I conveniently have a right triangle here, and I do know that this angle right here is 55 degrees, I think I'm going to opt to use my trigonometry, my right triangle trigonometry. This is my opposite side, and this is my adjacent side. So if I do TOA, right, that would be tangent, is opposite over adjacent. So I'm going to do tangent of 55 degrees equals opposite, which I know to be the 29, over my adjacent, which is that green piece. I don't know what it is. So I'm going to go to my calculator. So I'm getting for tangent of 55, 1.428. And then we're going to cross multiply. And so we get 0.428x equals 29. To get x by itself, we'll divide by 0.428. 29 divided by that comes out to 20.306. Okay, so if we know that the green segment is 20.306, then we know half of the length of the square from here to here is 20.3, and so that means, since this is a square, that means the other half is 20.3. So that means a whole side length would be 60. Whoa, accidentally multiplied by 3. Make that a whole side would be 40.61. So now that we know a whole side of this square is 40.61, we can go figure out our perimeter. So we have 1/2 times our perimeter is going to be 40.61. And when I say that, keep in mind I'm using all the I'm using all the decimal places. So 0.612037 times 4 sides to find the perimeter of the whole thing, right? And then this is still, I'm going to have to erase my tangent work over here. This is still times the slant height plus the area of the base, except for now we can find the area of the base because it's a square. So now I know that all the sides will be 40.612. So that times itself, right? Base times height. So I'm just going to call it that squared. Okay, so we're on the right track. We have one last piece to do. We need to find the blue slant height. So a couple of options now. I could use the Pythagorean theorem, or I can use SOHCAHTOA again, sine, cosine, or tan. I think I'm going to opt to use sine, cosine, or tan. Since my slant height L is my hypotenuse, I'm going to use my opposite, which is still 29, and my hypotenuse L, so that would be sine 55 equals opposite, which is 29, over hypotenuse, which is L. So 0.819 L equals, when I cross multiply, 29, divide both sides by 0.819. Again, I'm using all the decimal places. I'm just too lazy to write them all down. And so 29 divided by that number comes out to be 35.402. And so now we can fill that in for our slant height. So 1/2 of that 40 times the 0.612037 times 4, running out of room, plus the 40.612 squared, and again this number I'm also using all the decimal places. Whew! So we're going to put that in our calculator. And for my final answer, I'm getting approximately 4,524.8698. So that would, to the nearest tenth, be 4,524.9 feet squared. So we're going to skip this last problem on the note packet for now, and we'll do that at a later time.